Right, so this little video is about the trapezium rule. And then trapezium rule is a numerical way of finding out an approximation to an area under the curve by essentially splitting underneath the curve between two limits, which would in this case are A and B, into trapeziums. Now, the reason I say numerical is this is where you would have numbers, and you put the numbers into the formula to work out the answer. It's different from an algebraic integration, because an algebraic one would be you worked it out with x's and y's or x's and sines or tans or whatever, and then you would put in your a's and b's at the end. Now that gives an exact answer. This is only an approximation. So if you think about it, we've got, you're going to split up underneath your curve into various trapeziums. Now, the reason it's an approximation is because depending on how many strips that you split this into, which will usually be given in the question that you're doing, you will get a straight line at the top. So what I've done, I've taken these underneath the curve, I've tried to expand it here, giving you a bigger picture of it. So we've got all of these trapeziums, and underneath the curve they will be right up against each other. So the reason it's an approximation is because this is obviously a curve and these are straight lines. So the straight lines here, if the curve is, you could have it slightly below or slightly above the line that you're trying to do. So that's why it's an approximation. Now, the trapezium rule obviously works down on the areas of these trapeziums. Now, the area, this is what you might be used to seeing for the area of a trapezium, but this is what it looks like from the area under the curve. Okay, just going a bit out of focus there. Right, there we go. So this is the area of a trapezium. This is a trapezium, or you could call it a trapezoid. They're exactly the same thing. It doesn't matter. Okay, so I'm just going to add on something here so that you can see why it is, the formula is the way it is. Actually, let's put that in purple and this part in green. Okay. Oh, hang on, not, yeah, up there. Right, up there. Right, sorry. Okay, so the area of this trapezium is, let me write it here. So it's A, hang on, can't see that very well. A, oh, hang on. A plus B. So A plus B multiplied by the height, which is h, all divided by 2. Okay, now let me explain that a bit more from the diagram. So we're going to take A plus B, so B, I'm going to add on the length of A up here. So this length here is B plus A, and this length up here, it's the same length, so it's A plus B, which is where this comes from. Okay, so you're essentially working out the area of a rectangle, which we all know is the length times the width, or in this case the height. So we've got B plus H times the height, and then we don't want all of it because and then it would just be divided by 2 to give you the area of the trapezium. So the rest of the area that's left will be the same size as this area. And you could split it up into rectangles and all of this, so you could then see exactly why it's half. But I'm not going to go through that now. So this is the area of a trapezium. A plus B times the height divided by 2. So if you turn the trapezium on its side, which mirrors a bit more about how it looks underneath the curve, you get A plus B divided by, times H divided by 2, okay, for one trapezium. So the trapezium rule is then we've got h divided by 2. So all we've done is take this h plus 2 out, and then we're left with the a plus b's in the inside of it. So let's have a look. I've just done a larger picture of underneath here. So we've got to add this one to this one to this one. Keep going, keep going, keep going until we're in the last but one. Okay. So we have, you think about it, we've got to add up then all of, because we've worked it out, it's a plus b, which is the 2 lengths. We've got to add up all of those 2 lengths. Now, when you look at these, you've got y0 plus y1 plus y1 plus y2 plus y2 plus y3, and then it would be plus y3. So can you notice the pattern that we actually have 2 lots of y1, 2 lots of y2, 2 lots of y3. So the formula then becomes, we only add in the first one once. We don't have that again because it doesn't come up again, because it's the first one, and that happens at the last one as well. So for here, that would be that length there, and for the last one, it would be b. Okay, so the last one, it would be y to the n. Okay, every one in the middle is twice because it's in one trapezium and then it's in the next one. So this one, the y1 is in this one and the next one. Y2 is in this one and the next one. So that's why it's add 2 lots of y1 plus y2, etc., until you get to yn minus 1. So running out of room, plus y to the n. Okay, so the only other bit of information that you really need is to work out h. Now, h is the width of these. But actually, when we look at the trapezium like this and then flip it round, it is actually the height. So that's why it's an h and not an x. Okay, so the h is, you will usually get given in the question how many strips you need. So it's essentially taking away, you're going to work out the difference here. So that's taking away a from b. So b minus a divided by the number of strips that you want. It will be different in every question. So just read the question. So that's how you get h. And then it is a simple case of whatever it is, you then work out. So that's why the trapezium rule is the trapezium rule. Hopefully that's helped you remember how you, remember the formula. And then you just need to do a little table. So we've got x and we've got y is f of x. So we're going to put in, you first of all work out what your height is. So depending on how many strips there are. So and then that will tell you how many x's you need. So you might need x1, x0, 1, 2, and x3. And then from here, you then work out your x values, whatever they are. And your x values are just the numbers along here that you've decided. So we've got one. So we've got 1, let's say that's x1, that's x, x0 is always a, x1, x2, x3, and x4. And then whatever your f of x is, whatever your curve is, put that number in and you pop it into the equation, and that's where you get your y out. So you then would get y0, y1, y2, y3. Okay, and then whatever those are, pop it in to your formula, and that's what gets you the approximation. And just make sure that you are giving it to what they want, whether it's 2 significant figures, 3 significant figures, or anything like that. Okay, so good luck with that, and let me know how it goes. Thanks, son.